Good afternoon, everyone. My name is Mylon Thompson-Bukovic. I'm the Vice President of S3 and Glacier, and I'm here to talk to you today about the world of storage. I am thrilled to have you in this room because I know it took a walk in the rain, and I'm very sorry for bringing it from Seattle, to get here. And you know what that tells me? It tells me the people in this room are serious about their storage. That's what we like to see. So here's what we're going to talk about today. I am going to avoid the laundry list. The laundry list is where you see bullet list after bullet list of new capabilities. What I'm going to focus on is to walk through the mental model for how you should think about the different storage offerings in AWS and what to choose for what adoption pattern. And I'm going to try to highlight the key takeaways for everything that we have in the storage portfolio. And my goal is that you not only walk away with a general understanding of AWS storage, but you walk away with some specifics for what you can do next, for what particular things you want to follow up on for your own personal application of that storage. So I always like to start with a big thank you. Thank you to everybody who uses our object storage, our block storage, our file storage, and our data transfer services. You are why we come in every day, and as you know from what you see on the slide, there are a lot of people who are using AWS storage. It's one of the reasons why Gartner has consistently put us in the upper right-hand corner of the Magic Quadrant. It's because we not only have that passion to give you the breadth of what you need, but we're pretty hardcore about going deep and giving you individual features as well. So let's talk a little bit about storage adoption patterns. S3 has been around for 12.5 years, and we have been working with customers for that entire time on not just S3, but many other storage offerings. And we've learned a few things. There are generally 3 adoption patterns that we see. The first one is rehost. Rehost is another word for lift and shift. It's an adoption pattern where you have something on premises, you want to take the whole kit and caboodle and move it over to AWS. Re-platform is where you want to take one slice of what you have in your application, and you just want to move that one slice over to AWS storage. And you keep the rest of your application as is, because you want to get the benefits of managed storage while still not changing the compute side of your application. And then the third category is re-architect. And re-architect means you have storage in the cloud, and you're going to build your application. And whether that's a rebuild of your application, or you're just starting out, and you know there's no reason not to start with new applications, but to put them in the cloud, and you're in that mode. Here's the interesting thing. You would be surprised how many seemingly conservative customers start with re-architect and later do lift and shift. These 3 adoption patterns are not sequential. That is my one big takeaway from working with customers over the last 8 years I've worked on AWS. It's not sequential. People pick the adoption pattern that matters for their business. So the typical pattern for the lift and shift is going to be working with EBS and EC2, like Lionsgate, the movie production firm. And the lift and shift move often ends up being triggered first by cost. People just want to save money. So they lift and they shift it into EBS and EC2, and they immediately get cost benefits. But if you're Lionsgate, you got agility benefits as well. They're not able to deploy more frequently. They're also saving millions of dollars, and they're able to do both by lift and shift. Now, when you lift and shift, you get those 2 benefits. But you sometimes don't get all that you could. FINRA is a regulatory body for the US Stock Exchange. They are a consumer watchdog. They watch every single transaction in our US markets. And their mission is to scan all of them and within 24 hours find instances of fraud. They were having a hard time doing that because they were working with storage that were in what they call data silos. in data centers, on data appliances. And if you're trying to crawl 24 hours of lots of transactions, they were rapidly approaching a point where they couldn't fulfill their mission. So they looked at lift and shift, and they said, well, yeah, that seems like I could do it, but it didn't solve their problem. Their problem was the SLA. How do I actually scan everything in the SLA? And the lift and shift moved them into AWS, but it didn't solve the problem. So they wrote their whole application as their first step for going into the cloud. That is what's really interesting about this pattern. We have many customers like FINRA who take that first step by taking the most important mission-critical application and rewriting it, because they need the benefits that they get for scale right away, and if they take another adoption pattern, they won't get it. Now, re-platform got a lot more interesting here, and this is because we have a lot more options that I'm going to talk to you about our managed file systems. But in re-platforming, what people do there is they take, for example, Storage Gateway, which is a drop-in solution. It works with your existing legacy storage protocols, tape protocols, and it backs your storage. It's essentially a cache, if you will, managed cache, into your AWS storage. And so you're replacing something. You're not re-architecting, and you're not lift and shifting. You're putting a new piece of architecture, the Storage Gateway, which is a virtual appliance, seamlessly into your on-premises environment to start getting the benefits of the cloud. The other thing that you can do is you can use one of our managed file systems, our new Windows file system. That is an example of re-platforming. It's taking your on-premises Windows world, and you're now using instead managed Windows file system from AWS. I'm going to talk a lot more about this. So think about some of these different ideas here. You can tell from some of the logos that we have customers who have done this. BBC is a great example where they took Elastic File Service and they use that as their re-platforming for their red button application. But we have many more examples of where customers are mixing and matching their adoption patterns based on what they're trying to do. I will say that although FINRA did the re-architecture for their major application, or mission-critical application, they're doing lift and shift too. They have workloads in their organization where lift and shift is the right solution for them. So look at these different patterns as what you do for the right time for your business and what the mission is of your business. So when we think about storage, we think about building blocks. And what we provide is more building blocks of different types of storage than any other provider. And what we've done this week is we've expanded it significantly, particularly in the case of file. If you take a step back and you look at the world of file systems, you have Linux file systems, you have Windows file systems, and you got a mix and match of a bunch of other stuff, but HPC is in there, right? There's high-performance computing file systems. And what we did with reInvent this year is we filled out the portfolio for AWS Storage and managed file services by adding Windows, FSX for Windows, and FSX for Lustre. Now, you can pick from basically all the file systems that you would need, and you can pay as you go. We can manage the infrastructure for you, and you can get the benefits of either a re-architecture or re-platform in that mode. Windows is more akin, I would say, to the lift and shift. Kind of depends on what your application is. But regardless of what you're trying to do there, we now have this very comprehensive list of elastic file services. The other thing that we've done for EFS, which is the Linux-based file system, is we've added, or we're adding, it's coming soon, an infrequent access tier. So if you think about your file servers sitting around right now, there's a lot of files on them that aren't accessed very much. And what we're building into EFS for Linux is we're building in the ability for you to set essentially a rule that says, if I have a file, I'm just going to move it over into Elastic EFS IA, and I'm going to save over 70% of cost. That's the type of thinking we do for building blocks. So I'm going to go through each of these in more detail a little bit later. The other storage classes that we introduced for object storage are intelligent tiering and deep archive. Intelligent tiering is the first cloud storage service that automatically tiers for you based on the access patterns of your objects. So, if your storage has frequent access patterns, you basically pay the same amount as standard storage. But if your storage in that month doesn't, you pay standard infrequent access, but you don't pay retrieval fees with this new storage class. Instead, you pay a very small per object monitoring fee. It's 1/4 cent for 1,000 objects. And what that lets us do is watch the last access time for your individual objects in storage and help cost optimize based on your access tier. It's the first ever storage class offered to do that, and it's already incredibly popular. We launched it a day and a half ago. We have petabytes in it already. So that is something for you to check out if you have variable access patterns for your storage. We also announced in Andy's keynote Deep Archive. Deep Archive is essentially the coldest glacier you can have. The retrieval times are 12 hours compared to Glacier's retrieval times, where you have different options for shorter retrieval times or longer ones. And it's 12 hours, but it's less than 1/10 cent. Think about that. $1 per terabyte per month. And you can get it back in 12 hours. And unlike tape, you're not going to have to send the tape back because it didn't work or was rotted or something like that. You're not going to have to manage those rooms of tape architecture that you have sitting around. You just get your data back. And if you want to have audit logs, we do fixity checks on all the data in Deep Archive. That's the type of thinking we do on building blocks. How can we not just provide for a few of your applications, but we want comprehensive coverage across block, file, and object. So let's dig into a few of these. Let's start first with Windows File Server. What's interesting about this is that it's really Windows, okay? So the Windows File Server, the Amazon FSx for Windows File Server, it supports all the way back to Windows Server 2008. Okay, and Windows 10. That was a long time ago. And so if in your environment you have, for some reason, some of these legacy Windows installations, we'll support all the way as far back as that, and you'll never have to manage another upgrade or patch again. Because once you move to this managed offering in the cloud, we do it for you. It has LDAP integration, it has AD integration, it has the right performance you want because we managed to build it to scale. And there's an ability to connect through to EC2, Workspaces, AppStream, and VMware Cloud on AWS. So this one is super interesting as a first step. Let's say you haven't taken a step into the cloud with AWS Storage. This is a great place to start because chances are you have some Windows storage in your environment, and you can get started with this in a lift and shift design pattern and get the benefits of the cloud right away. So we have customers who come to us, and they want to do HPC. They want to do high compute, intensive compute operations on top of storage. And so we looked around to see, what are the file systems that people are using? And it turns out that lots and lots and lots of people like Lustre. Lustre is a parallel file system, and it's been a community that's been around since 2006. It's an open source community. And Lustre is the preferred choice for many of these HPC applications. And so what we did is we launched a file service based on Lustre, but we made it managed, and we plumbed it with S3 buckets. So what this means is that if you have a data lake, or you're thinking about a data lake in S3, you can pull the data out of your S3 bucket into Lustre, and you can get the super intensive performance that you need for the HPC-style computing, and then you can push the output of that back into Amazon S3. So not only do you get this managed high compute capability, but you also get that deep integration with S3 that opens up a different type of compute-intensive processing for your data lake. It's really interesting in that way. And of course, the performance on this is just amazing. You can get more than 100 gigabits or gigabytes per second for throughput, millions of IOPS. The consistency on this is sub-millisecond. And it's all because it's SSD-based, and it's using this parallel file system that has been proven in time across many HPC type of applications. So this is the model that you want when you want that super high throughput, that super high IOPS processing on top of your data lakes. The idea that we have behind intelligent tiering is that the needs of your access will change sometimes, and you will not want to track that. So our model for S3 is that we have different storage classes. We have standard, which is a general purpose storage class, and then we have specialized storage classes like standard infrequent access, where you save 40% on the cost of standard. Works great if you already know that the storage you're putting in there is only going to be accessed, say, once a month. But let's say you don't know. Or let's say it changes day to day, week to week, month to month, and you don't want to track it. You don't want to make a decision, which one do I put it in? You put it into this storage class. The only reason you wouldn't use S3 Intelligent Access is if you have lots and lots of small objects, because you pay a per object monitoring fee that lets us check on your last access time, but we're not going to do the cost optimization for anything under 128K. So if you're generally operating with larger objects and you don't know the patterns of change that you have, this is a great option for you. Coming soon is this infrequent access. The rule that we're using for infrequent access is if it's touched once a month. So if it's touched once a month, it automatically gets moved into infrequent access, and it's rehydrated out of that infrequent access tier for you without suffering any loss of performance. That is a really important concept here. We, just like intelligent tiering, are optimizing access for cost, but it does not come at a performance penalty. We're pretty excited about Deep Archive. We think it opens up a lot of things. Obviously, tape. Obviously, tape. I mean, really, if you're managing tape on premises after this is available, you are taking so much work you don't have to do, and the product that you get with tape is so less capable than what you have with Deep Archive. Those fixity checks in themselves are worth the move, and the price is kind of unbelievable. The idea here is that you have the same durability as Glacier, and you have the 12-hour retrieval time. And a lot of data, I will tell you, is very tolerant of 12-hour retrieval times. I talked about this a little bit this morning in the Werner keynote. S3 now is exabytes. We have tens of trillions of objects. And a lot of the growth is driven by data types that you might not think of. There is a vast amount of unstructured data out there, and it ranges from customer call records. We have mapping data. We have backup and sync. I mean, really, the list kind of goes on here. But one of the fastest growing use cases for S3, and this has been true for years now, is data lakes. S3 is the best place for data lakes. We have over 10,000 data lakes on S3, and that is conservative. There are way more than 10,000 on S3. Why? People put their data in S3 for data lakes because we have the best performance, the best durability. All the fundamentals are rock solid, but we also have an incredible variety of different services that you can use with the data lake in order to make that more useful. EMR, the new service that was launched, which was Lake Formation. Lake Formation basically makes it very easy to set up data lakes. It uses ML for data cleansing. It centralizes your access controls in one place and lets you be able to audit and manage them. And it's free of charge. All you pay for is the resources like S3, but it makes it really easy to set up a data lake. And the reason why we're building things like this and new capabilities that you can do on top of a data lake is because so many of our customers are often starting there to get that benefit of cost and agility. So I'd like to welcome to the stage Clay Gerard, the Director of Data Services and Platform from Expedia Group, to share more about his experiences. Clay?
Thank you, Milan. It's a real pleasure to be here, and I'm looking forward and excited to share with you what we've been working on at Expedia Group. Now, I imagine that many of you, just like me, probably have used one of Expedia Group's websites to book your travel. And some of you may even have done so without realizing that you were using one of the brands that is owned by Expedia Group. When I first started working at Expedia, I had no idea that all of these well-known travel brands were part of the same company, or the sheer size and scale at which the company operates. But being in the group that is responsible for providing the analytical data platforms for the entire company, I now am well aware of the size and scale at which we operate. So because our company has such a global reach, global employees, global customers, it's led us to some problems that I think are common for companies that are like that. If an analyst over here needed data that was sitting over here, we would just pick up that data and move it, make a copy of it. But then he might make some changes to the data, and someone over here needed the copy of it. They would just copy it again. So now we have a copy and a copy of a copy, and copies of copies, and as you can imagine, it became quite a mess. But we needed to position our data both close to our customers and close to our employees to provide the best service that we possibly could. Some of these other issues that I have listed here, lack of a central catalog, no way for us to know where the authoritative source of the data is, data that existed in silos, either by brand or by geographic region, inconsistent or non-existent lifecycle policies, and no real way for us managing access rights. The rights aren't traveling with the data whenever it gets copied. These are all problems that we were trying to solve. So after analyzing our current footprint, which I would describe as many tens of petabytes of data in many geographic regions, and understanding the behaviors that had led to our current situation, we came up with a plan, something that we called the Expedia Group Federated Data Lakes. And you'll see here a list of some of the technologies that we used and employed to solve these problems. Some of those choices are relatively straightforward and easy. Other ones were more nuanced. This is not the only way to solve these problems, but it's the path that we took. Using S3 as the backing file store, object store, made a lot of sense. The durability and cross-region replication 100% got us where we needed to go. We then developed an open source product, the Expedia Group Apiary product, that we use for federation to help us control who has access to the data across all the different clusters that we support. Amazon EMR for distributed query processing, once again, pretty straightforward decision. I don't recommend copying data unless you need to, but in our case, that frequently does come up, and we use data pipelines combined with another Expedia Group open source project created by the Hotels.com engineering team called Circus Train to both orchestrate the data movement, make sure the data is moved, and then validate that the source and destination data are the same. We do have a third-party product that we use as our master central catalog, but for local catalogs inside of the clusters, we use Glue, which allows us to very easily use Athena to do ad hoc querying. And then, as Milan mentioned, intelligent tiering. If you're going to accumulate mountains of data, having a system that will automatically move that data to lower cost storage tiers is a great thing. The partnership with AWS has given us some very tangible, real benefits. Speed of innovation. If you can take a process that would normally, from a development standpoint, take you months and reduce that to weeks or days, that's a very clear win. The seamless interoperability of these services also means that the individual parts are valuable, but the sum of those parts are far, far more valuable. Cost savings is not something that most people might associate with the cloud unless you're talking strictly about elasticity, which is important. But as an example, intelligent tiering is an example of where you would save costs as well. But also the direct support for Spot in EMR is another case where we did a little bit of investigation, turned that on, and very quickly saw about 70% savings in some of the workloads we were running. Our federation allows us to more easily share data-driven insights across the company, and the global availability of AWS means that everywhere we are, everywhere our customers are, they are too. It's one of the reasons why I say that with the power of AWS Storage, Expedia Group is creating the future of travel. I'd like to leave you with a few takeaways. This is what I call my regret slide, things that I would have done differently had I known these things at the beginning. I'm sure none of you have similar regrets. So copying data is necessary to, a lot of the time, you're going to have to do it. But don't do it unless you have to. This idea of copying and making copies of copies, it's a bad pattern. And if you think that it's difficult to look through hundreds of terabytes of data, when you get to hundreds of petabytes of data, it's almost impossible. Which kind of leads to the second point, lifecycle policies. When the data is created, the data producer understands the value of the data and the life cycle that that value has. You have to set the policy at the creation or ingestion time. That way you can have automated systems actually remove the data so that you don't end up accumulating it. And then the last point that I wanted to make is around cost optimization, which is something that I've spent the last 2 years spending a lot of time on. It's not an activity that you should just perform once and you're done with it. It's not something that can come at the end, and we're going to spin up an entire team who's going to do a bunch of work. It really has to be built into your thought process. It's a mental shift that needs to occur. When you're designing your application, when you're designing your data storage, think about how am I going to define, what are the metrics I'm going to use to define the business value that I'm getting out of this service, and then track your costs against that so that you'll have a clear indication when you need to reduce costs, increase value, or perhaps shut down the service. I just want to say thank you for your time and safe travels.
Thank you, Clay. One of the things I love about reInvent is when our customers like Clay get on the stage and tell you what to do differently for the next time. We all have these lessons learned, and our goal here is to pass them on to you. Our goal on AWS Storage is to give you the tools to do all this. That's what I'm going to talk about next. Part of what we think of when we think of how data lakes, like the one that Clay talked about for Expedia work, is everything from a low level up to a feature capability. So I'm going to start from a low level. Performance is very important. And so one of the things that we constantly architect for in our AWS storage services is how can we continue to increase the price or increase performance. And in this case, we're not increasing any of the cost of it. We're just giving you better and better performance. Earlier this year, we made a pretty big change to our performance. And if you look at some of the write time, read time here for the before, and you look at it in the after, this is looking at taking 5 terabytes of 2 megabyte size objects that is talking to one prefix in S3. And before it went from, the query was taking 41 minutes for writes, and it dropped down to 12 minutes. And in terms of reads, it was 13 minutes, and it was dropping down to 7 minutes. Now, what's interesting about S3 is that our request performance is based on a per prefix rate. It's not on a bucket, it's not on an account, it's on a per prefix. And so our scale out pattern means that you can actually get to very high performance rates by just spinning up more EC2 instances and going after your prefixes. And so, in this case, we've increased our performance to such a degree, and we've increased the breadth or the wide requests performance, the aggregate performance to such a degree, you no longer need to do any kind of special naming for your object prefixes. In the past, you had to name your objects in a certain way to randomize the first characters so that you could hash it across our key space. You don't have to do that anymore. Our performance individually on a per prefix basis is so high now that you can do basically anything you want for object naming, and you can use this pattern of basically spinning up more and more EC2 instances to go wide to get the performance that you want. So I talked a little bit about the building blocks. This is all the work that we do within the building blocks. And there's a lot that we've put together. I'm actually going to start with block storage first. So block storage this week has increased your GP2 performance by 60% and doubled your provision IOPS throughput. As I said, performance is job one, along with security and durability, and that's what you get today with EBS. Earlier in the year, EBS has launched things like making elastic volumes possible on any volume type. It's added encryption to the incremental snapshots. And it's introduced an EBS data lifecycle manager. If you are using block storage, you are probably using snapshots. It's an incredibly popular capability for EBS. The data lifecycle manager actually takes all the work out of managing your snapshots. It does the scheduling for you, and it makes it policy-driven in a way that makes it easy to manage snapshots on top of block storage. So EBS, like our other storage services, we don't just think about performance. We think about the tools that sit in the service as well that make it easy to not just manage, but to use the actual storage itself. Whole lot of work done for file storage, as you can see. Mostly in the EFS world. I think one of the most exciting things was the idea is when we introduced encryption in transit for EFS, and we added HIPAA eligibility. I talked a little bit about Windows. The Windows file system, that is PCI compliant and HIPAA compliant from the launch point, so as of this week. We added that for our other Linux-based EFS earlier this year. In object storage, we've done a lot over the last year, but I want to call out a few things. S3 block public access was launched a couple weeks ago, and I strongly encourage just about everybody who uses S3 to use it. What block public access does is it allows you to set a policy at the account level that blocks any public access to any object or bucket already in the account, and it blocks it for the future objects and buckets created in your account. That is incredibly powerful. People accidentally change our by default secure settings. They don't mean to sometimes. They just do it and they forget about it. And if you have block public access, you're protecting yourself, them, and your company from that being done. Now, sometimes people have perfectly legitimate reasons for having public access to a bucket. My recommendation is that you create a separate account, a super secret account that nobody knows about, and you put those public access buckets under that account, and everything else that you use to create new objects and new buckets is under block public access. Security is job one for all of us, and we'll keep on building new capabilities for this. The other things that we've introduced are batch operations. I'll talk a little bit more about that. And we've done a lot of work about bringing S3 and Glacier together. We've also introduced some new data transfer capabilities. I'll go into that in some detail, but it's going to make ingest for your storage a whole lot easier. Here is a summary of all we've done for security, and I wanted to capture this for folks because all of these are capabilities that you have today. We have free checks for AWS Trusted Advisor. We made them free. They're open bucket checks, so you can use them today. You don't have to pay any money for them. We have a bucket setting that says if you turn it on, any object coming into that bucket is automatically encrypted. Whether the developer setting the bucket into your, or the storage into your bucket is encrypting or not, we'll do it at the bucket level. We list encryption status in the inventory report of S3. Those of you who don't know what the inventory report is, you turn on inventory report, it's very cheap. It's very, very cheap. You just turn it on, and once a day, it'll give you a report of everything that's in your bucket. Part of the data in the report is the encryption status. And so we have security officers and many different corporations that use that inventory report to just check to make sure that everything is encrypted. We also, in the console, have that permissions check. So if you go to the console and you do it, you just look at it, we automatically sort the open buckets to the top. And then on top of that, we've added this S3 block public access capability. So think about all those different layers and make sure that if you are not the security officer for your company, that you're bringing that information back. Security is important for data, as you know, and we're going to keep on layering in capabilities like that. Another thing that we've added is to introduce the ability to increase the performance for EFS. And this is really to allow for bursting throughput. Okay? So, you know, I think the interesting thing here is we're not only improving the bursting throughput for EFS. As you can tell, we've taken it down from the type of bursting that you can have to go from 2 hours and almost 3 hours all the way down to 1 hour and 12 minutes. But we also have the same design pattern, okay? So that measurement that I provided before was on one instance. You can actually significantly increase your provision throughput capability if you work with multiple instances. This is a design pattern that is true for object storage as well as ESF for provision throughput, okay? When you think about your block storage, you know, the key things that we call out are not just the performance improvements that we've made for this week, but it's also about the additional capabilities that we've added to make it both simple and reliable to use EBS. Now, EBS is super interesting because it's where a lot of people start first for the lift and shift, but we do have customers who re-architect and they use EBS because they're using EC2. And it is incredibly high performance now. And in fact, if you look at some of these performance rates, this means this is transactional database ready type of performance. So think about that, not when you're just doing a lift and shift, but also when you're doing re-architecture and you're building your new applications and you're thinking, what kind of storage do I use for that? If I think back to, I would say, 3 years ago, that's when we first started to work very hard on manageability. And the trigger for us is that our storage was growing at this incredibly rapid pace. And across all of our storage services, we had customers coming to us saying, great, Elastic Storage, I love it. Oh my gosh, how do I manage it, right? I mean, the benefit of Elastic Storage is that you can put all you want in it. And then you've got to actually control it. You have to be able to lifecycle it, tag it, manage it. And we started to build these capabilities. And as you can see, we've added quite a lot. And so what we do is we tend to classify our manageability into a few different areas. The first thing we think about is tagging, okay? So tagging is a capability where you can put up to 10 editable tags on every single object. Now, we treat tags as a first-class semantic, which means that if you set up a cross-region replication policy and you're replicating your storage from one region to another, you can specify the policy to only replicate what is tagged. And that means you can save a lot of money, because you can replicate only the most important storage that you want to another region. You can also use tags with lifecycle policies. So if you set lifecycle policies to expire data or to move it to a new storage class, you can do it specifically on tag. So your business logic goes into that tag, and then you use our engines, our policy-driven engines, to operate off of that tag. We added a ton in monitoring. So we have Amazon CloudWatch support for metrics, and we have CloudTrail data events. CloudTrail data events is something that I would recommend everybody use as well. The worst thing is when somebody comes to you and says, I think somebody is accessing that object and they shouldn't. Maybe I set up the wrong permission. Can you go back and check who's accessed the object for the last 2 months? And you're like, well, I could, but I don't have the data. If you turn on CloudTrail data events or you turn on server access logs, you have the data. You can go back in time, and you can go back into your logs, I should say, and you can pull out the information that you need. And CloudTrail gives you that extra benefit of being able to set an alarm on an event occurring against your storage, and also to do that deep monitoring. The other thing that we introduced is inventory. We introduced this last year. I believe it was last year. And I would say that the vast majority of our biggest 200 customers use it. A, because, as I mentioned, it's really cheap to turn on. You're not even going to notice it in your bill. And two, people start to build business processes around it. It's basically just a list of all the objects in your bucket. And you start thinking about that and going, well, I could probably start doing some business analytics reports on that. And my security guys probably want to see it because of the encryption status. It starts being more and more useful of how you think about what's in your storage. We also introduce a couple of tools, or we combine them, I should say, for being able to tier. So storage class analysis is something we introduced because customers said, I have a lot of data in standard and I want to move it to SIA. So we introduced storage class analysis, which gives you a recommendation for the types of objects that you move into SIA. We've built on this by adding the capability to do more between, if you think about storage class analysis and lifecycle, those are two building blocks that you use together for tiering. The intelligent tiering storage class has that built in. So I talked about that before. You can still do those two building blocks together, but if you don't want to think about making those decisions, then you use the intelligent tiering storage class. Now, one of the requests that we've heard for a long time is how can we make it easier to use Glacier Archive Storage, which is as low as 0.4 cents in cost, with the S3 API. And as of this week, we are introducing a set of new capabilities. The first one is fairly obvious. You can now directly put, using the S3 put API, into Glacier. You don't have to put it into standard and then use lifecycle to tier to Glacier, which means you cut out a step of the process and you cut out your lifecycle fees. If all you need to have is your storage in Glacier and you want to use the S3 API. The other part of that is you can set up cross-region replication policies and put your data directly into Glacier in your destination region. This is really interesting for disaster recovery type of scenarios. When we launch Deep Archive next year, that is also interesting because you can have your primary storage class be whatever you want in your source region, and then you can either have your storage in the destination region be 0.4 cents or less than 0.1 cents, depending on what your tolerance for retrieval is. That's pretty exciting. We also have introduced a set of new capabilities around how you can modify and manage your storage. I'm going to talk about that in a little bit. So one of those capabilities is something that we call batch operations. As I mentioned, about 3 years ago, we started to do more on manageability. And we have many customers now of S3 who have millions, and in some cases, trillions of objects. And they have to write applications to manage those objects. And so what we did is we wrote batch operations. It's a feature. Think of it as a framework. And you can do certain actions within the framework. And so what batch operations gives you is it gives you the ability to execute an action across a manifest of objects. You can use the S3 inventory report as your manifest, or you can just look at the schema and create your own manifest and use that instead. And you pass that into batch operations, and we will take an action against every object you specify in your manifest. There's two categories of actions. You have one category, which I would think of as native storage actions. That's replace a tag set. So I talked about tags as a first-class semantic that you can do lifecycle or cross-region replication. This lets you put a tag set on millions or trillions of objects very simply or even through the console. It lets you replace your access controls on a per-object basis. This is what a lot of security officers want to do. It lets you manage restoring objects from Glacier. So you can do that in essentially bulk. It lets you copy objects from one bucket to another. Very common for dev test scenarios. And here's the interesting, that last item is a separate category all to itself. It lets you run a Lambda function against the manifest of objects that you specify. That is a totally different programming model, right? Rather than doing the storage-specific things, you're now opening up this huge horizon of opportunity for business logic that you now apply to your objects. And so that can be data cleansing, that can be image manipulation, that can be inserting ads into a file. I mean, there's so many different things you can do with this, and it's all driven off of the serverless model of Lambda, but applied against the many millions, trillions, thousands. The number doesn't matter. If you're managing anything more than a few objects, this makes it very easy. It's now in preview. If you send us a note, you contact us. I think on the website we have some way to contact us about this. Then we will add you to the preview if you're interested and you want to play around with it. Or it will be available early next year for you to use for general availability. So our idea here with the archival storage for the S3 API is that not just Glacier storage classes, but all future storage classes, including Deep Archive, are going to be able to be added through the S3 put. Okay? So what that means is that no longer do you have to use lifecycle with Deep Archive either. You can now directly put into Glacier or in the future Deep Archive through the S3 API. What we've also done is we've added more integration to a few other types of features that are used by Glacier customers. Talked about the direct put. We also introduced object lock. This is basically Worm. Worm support for S3 objects. Glacier added it a couple years ago, I believe, and we have it as well. I would recommend you look at this even if you don't have Worm storage, because we have a setting in there called governance mode. And basically, the way to think about governance mode is it's a privileged delete. You're saying that only this privileged user is allowed to change the policy. It's allowed to change policy on this particular, the duration or the retention policy on this particular object. And so you don't have to really need the Worm compliance and the, you don't have to use it for compliance. You can actually use it for locking down retention policies, and maybe not with the, the Worm permanence of it. If you move in governance mode, it's basically working as a privileged delete. And we think a lot of enterprises are going to want that for certain types of storage. We also have restore speed upgrades and restore notifications. So right now, when you restore from Glacier, you have to wait until the restore is complete before you do another restore if you need it. Let's say you have a situation where you've entered a restore for 12 hours. Let's say four hours, okay? And you are, your HR team comes to you and says, oh my gosh, I totally need it right now. And so what you can do right now with the restore speed upgrade is you can enter a request and you can override the previous 4-hour upgrade or restore, and you can go to 2 to 4 minutes. And so that gives you a lot more flexibility of how you get your data out of Glacier. The other thing that we launched, and this is more of a programming model thing, again, super interesting, is restore notifications. So with restore notifications, you will be notified and can trigger other workflows as soon as the restore is complete. You don't have to wait around or check back or do anything like that. You get notified. And what that opens up is a lot of business workflows that operate off of the data that you restore out of Glacier. So if you think about it, these type of features make it a lot easier to get data out of Glacier. With the addition of Deep Archive, you now have this really nice span of different options to manage your storage. You have Deep Archive, 12 hours. No flexibility in speed restore. It's 12 hours. You have Glacier, where you do have flexibility. Now you have extra tools where you can actually override or change whatever restore speed you used, and you can get notified when it's done. That's a little bit more active, right, for your archive storage. And then you have standard and frequent access, one zone and frequent access for copy data, should you have it lying around and want to store it at a cheap price. And now you also, on the general purpose area, you have standard and you have standard intelligent tiering for those variable access patterns. The customers that we have with a lot of storage use many of these storage classes together to achieve the lowest total cost of performance. And so it's really important to be able to kind of understand the characteristics of each of those. All right, so let's talk a little bit about getting the data into AWS. So we talked a lot about the storage that's in AWS. How do you get it to AWS? This is often the first question, aside from what storage option should I pick, that our customers face. And we've put a lot of investment in here. In fact, many of the options that we're going to talk about are things that we've launched in the last couple of years. So we have a couple of different modes, if you will. We have capabilities that we provide for on-premises data movement into the cloud. And probably the thing that we use the most here is AWS Storage Gateway, which is that drop-in virtual appliance. Or we have partners as well. We have lots of partners that have integration with AWS, like AWS S3, and they use that. Now, if you think about our whole portfolio for data transfer, we have a lot of different options. We have Direct Connect, which just basically opens up a big fat pipe from on-premises into the cloud. This is for your high-performance type of workloads where you're trying to migrate data as quick as you can. If you want to move streaming, you have a couple of options, which is the Kinesis family. You have Firehose, data streams, and video streams. If you're trying to move very large objects from geographically distant locations into other regions, use transfer acceleration. Very common with, for example, medical labs. We have folks who use European medical labs or African medical labs, and they ship the data back into our Northern Virginia location. And in that case, they have a latency that's created by geographic distance. And what the transfer acceleration does is it removes that latency by going across the Amazon backbone and getting your storage into that region as quickly as we can. We have Storage Gateway, which is this drop-in capability. We've built it out tremendously. The File Gateway, for example, is something we launched last year. It's grown fast. And then we have our Snowball family. Our Snowball family we introduced as data transport. That's how we started. Data transport is basically, I want to get my storage from here, which is my on-premise environment where I don't really have networking and I can't really move my data very quickly. And I have this data that can be offline for a couple weeks. So I want to get it from here into AWS. And so we built Snowball, data transport. Customers came back and they said, I kind of want to keep that Snowball around for a while. I want to do some compute on it. And so we introduced Snowball Edge. And Snowball Edge had a lot of storage on it and a tiny bit of compute. And in this reInvent, we've introduced another Snowball, which is basically compute optimized with a lot less storage. And those are for more computational intensive operations that are out in the field. And when I say the field with the Snowball, I will tell you, I really mean the field. People take Snowballs everywhere. They send us pictures. All right. And then for those with the, just petabytes and petabytes of storage, there's always the truck. And we have customers who order a truck, and the truck pulls up to their data station or their data center, and they hook up the truck to the network in the data center, and they just move a whole bunch of storage, and they bring it back to AWS. Now, we've introduced two new data transfer services, and I'm going to talk about both of them in some detail. I think they're really important for any data migration type of scenario. First one is AWS Data Sync. This is new for reInvent. It's available now. I strongly recommend you try it because it just makes sense. So AWS Data Sync is agent-driven. You download an agent on premises, and what the agent does is it gives you this very accelerated online data transfer. It connects back to your file systems or your storage arrays using NFS, standard storage protocols. And what it does is it uses AWS Direct Connect or WAN to come up to the AWS region that you're using, and it talks to the data sync service to get the storage back in to either S3 or EFS. It is what you use if you want to get your data from point A, which is your data center, to point B, but it can't be offline. If it can be offline for a couple weeks, Snowball works like a champ. But if it can't, data sync is the alternative for that. And we built our own protocol for this. It's coming up over our backbone. We're trying to make it as performant as we can. And it's pay as you go. You spin it up when you need it to do your data migration work, and you spin it down and you're good. Well, SFTP. It's an oldie, but it's a goodie. And I'll tell you, it's going to be around for a long time because there's a lot of clients out there that use SFTP. And what we heard from customers is, hey, I just want to transfer files. FINRA operates SFTP infrastructure, and they're transferring 6 million files a month from 1,000 users. And so when we launched AWS Transfer for SFTP, they've moved to it because they don't want to deal with that SFTP infrastructure anymore, yet they need all of that integration with Active Directory and LDAP, and they really like the pricing of it. So here, this is just going to work with FileZilla and all your standard SFTP clients that you have in the world today, but you're moving to an AWS service to manage the SFTP transfer. I think this is going to be really important for a lot of different industries. We hear from insurance, we hear from medical, we hear from a ton of different verticals. Companies in those industries where these things aren't going away anytime soon. So we launched a new service that is AWS managed to help customers with this particular piece of infrastructure for as long as you need it. Now the edge compute, it's optimized for compute that we launched, is been quite popular for media workloads in particular, okay? And so, if you think about the other edge instance, it was sort of the reverse of this. We had a ton of storage, 100 terabytes of storage, and we had like what I would call a little bit of compute. And so that type of compute was okay when you're the University of Oregon going out on a research ship to collect data about fish patterns, and you're doing some basic data cleansing on the ship and then coming back. But it wasn't intensive enough for people who want to do things like a little bit of machine learning, or they want to do more computational intensive operations out in the field. And that's why we built Compute Optimized. What's interesting about these Snowball edge devices is we built them to be resident. You can keep them for as long as you want them. Just got to pay for them, right? But you can keep them for as long as you want them. We don't expect that you're going to send them back to us. And what it's done is it's made for particularly for a lot of countries where we don't have an AWS region, but we have Snowball Edge able to go there. It's really been able to create this clusterable set of snowballs that are kind of available for you with, again, a little bit of storage and a whole lot of compute. Opens up a lot of different scenarios for folks who want that kind of flexibility of their compute environment going wherever they want to be. Now, we have a lot of other storage sessions. What I wanted to do is just summarize them for you here. And the goal here, and I think reInvent is awesome and overwhelming at the same time. There's just so much information. And so what I wanted to do here is lay out all the different storage sessions. If there was something that I talked about here that you hadn't had time to go see and learn about, feel free to check the videos out afterwards, because I was only able to cover an overview of all the different capabilities that we have in the storage service, but these are the sessions that go and drill down. So I wanted to say, again, thank you, everybody, for using AWS Storage. Thank you for coming, and have a great show.